My name is Carl Dalton. Anil has asked me to talk today about cost estimating and cost engineering. Somebody mentioned on one of the previous presentations about the presentations. I'm more than happy for you to have a copy of this, so I'm not sure how you go about that, but if you don't get a copy, by all means contact me and I'll send you a copy. But as far as I'm concerned, you can have a copy of anything I present here today. There's a bit of a speaker profile. I won't go through that too much. Other to say I'm a fellow association of cost engineers. I've got a fellow over there as well, so I've got to be careful what I say here. But I'm also a directing partner in a couple of consultancy companies, Polaris Consulting and the Forecasting Centre, and I've been doing cost estimating for nearly 40 years. So hopefully I've got some good skills and knowledge to pass on to you today. So I'm going to talk about what is estimating. We all have our own opinions, especially when it comes to money. We all have our own opinions of that. But I'll give you a couple of definitions. I'll start telling you why I think it's important to do estimating. Need to go on its own. That's a bit worrying. What to include in an estimate, types of estimating, data collection, which is probably the most fundamental part of estimating. I'll talk about cost engineering. Really, what do we do with the estimate once we've got it? There's a whole array of things we can do. I'll spend a day talking about what we do with the estimate once we get it. Well, that's what I call cost engineering. And then the verification. You can't just end with an estimate. You've got to agree it. You've got to make sure it's sound. You've got the evidence behind it. And it's fit for purpose. I stole a couple of definitions here, one from the Project Management Institute and one from the Association of Project Managers, and I will read them. An assessment of the likely quantity results usually applied to project costs and duration. An approximation of the project time and cost targets that is refined throughout the project life cycle. Now, if I go away from here in the next half an hour, three-quarters of an hour, and leave you with the thought that an estimate is just a number, I've failed. It's far more than a number. Number is important because we've got to give a budget. You've got to assign resources. You've got to have a cost to work to. But it's more, just as much important, the things behind it, the assumptions, the data you've used, even the exclusions. So if you're assessing an estimate and you don't know whether things have been included or not, it's very dangerous. Somebody may have forgotten it. So the documentation is just as important, in many cases more important. The other thing we mentioned, we talked about cost estimating and cost engineering, but there's a time dimension as well, because time costs money often, so we have to look at the time aspects when we're doing cost estimating as well. So why do we undertake project estimating? Why do we estimate project costs? The quote on there, to establish a cost-conscious attitude at the outset of a programme to improve decision-making and increase confidence in budgeting and the allocation of resources. It'd be nice to have all that, wouldn't it? It's a wish. But why do we do cost estimating? We need to know how much things cost. There's so much pressure on budgets and monies at the moment, it's even more important than it's ever been in the past. It's always been quite important, but now there's a bigger emphasis on cost estimating. We are inundated with people asking us to do independent and cost estimates because people are concerned now. There's not much money to go round, so you've got to use it wisely. You've got to be able to set up your budgets, allocate resources. You've got to set targets. You want to know if a project is achievable. Have you got the funding to fund that project throughout its life, not just the early days? Are you getting value for money? You know, is this the best way of using your money? Often you have to undertake an investment appraisal to get justification. So you need an estimate to go into that. And once you've got a project, you need to understand when am I going to pay it, because cash flow is important to the contractor if you've got a contractor working on it, and within your own budget constraints. It's also, once you've got an estimate, it helps you look at alternative designs, alternative procurement decisions, making sure you make cost-effective decisions. Obviously, you need to make your investment decisions. You need to look at the operational needs. Does it fit in my total program of work? Look at alternative support concepts. But when should you do an estimate? You know, should you do it early in the cycle? Should you do it halfway through? Should you do it just before you set contracts? I think all of those. The earlier you do an estimate, the more uncertainty you've got, but the more influence you have on the overall design and support concepts and procurement options. So right at the front end of that chart there, in the left-hand corner, if you do an estimate at that stage, there's an awful lot of uncertainty, but you've got a lot more influence on the design and aspects like that. If you start doing it right down this right-hand end, it's probably too late. You've got a lot more certainty about what you're trying to estimate against, but it's too late to really influence many things. But you get a far more accurate estimate. So you've got to balance that. So typically you do an estimate right at the left-hand end when you're trying to set up your budget. Now, you do an estimate, you set up your budget, and people say, don't worry, we've got lots of time to get that right. But once you set a budget, a lot of you will know it's very difficult to get an increase on that budget. There's always a lot of constraints, so it's important to get that first estimate as close as possible within the bands of inaccuracy, and I'll talk about that later. You certainly do an estimate partway through, because things will change. You get better design, maybe, more knowledge. You certainly need to do an estimate later on, when you're just about to let the contract. You need a good idea, are you getting value for money? And the sort of contractor estimates and quotes you're going to get in. But what should you estimate? What should you be estimating? People typically think of the acquisition or the construction phase. That's where a lot of the big money is. But that's typically the tip of the iceberg. There's a lot more underneath. What about the support costs? What about the operating costs? The upgrade costs? Depends what the candidate equipment you're talking about. Is it a building? Is it a transportation system? Is it a defence system? And so on. But they all have the same problem. You will operate those. You will support those. Are you including those costs? One thing you typically do, if you're looking at upgrade or change something, you need to look at the cost of doing nothing. What is the cost of running this on? Well, if you're trying to compare that with a brand new building or something, or new construction, it's not a fair comparison, is it? So you've got to make sure when you're doing an estimate, you're comparing like with like. So one of the first things you need to do is decide what you include in an estimate. So what are the cost elements? Are you doing the whole life cycle? Going from cradle to grave, from the development, the manufacture or construction, the bringing it into some sort of operation, operating it, supporting it, or any of the above? Which ones do you need to include? You have to decide. You have to set up the ground rules from the start. For instance, if you're looking at a space system, do you just include the satellite that's flying off? Do you include the ground station? Do you include the launcher? Or any of those? So you have to understand the physical, if you like, the technical boundary. And if you're interfacing with somebody else, who pays for that? Does that need to be included in your estimate or not? This is where you need to document. What are you including in your estimate? It's very easy for somebody to come along and say, I want an estimate for that. Yeah, but what do you mean? Well, don't worry about that, just give me an estimate. How often do you as an estimator get that? You do. Don't worry about the detail, just give me the estimate. A few people are laughing, they've been there. You know, what you're getting, you know, you might think you've got apples and oranges. Well, that's not too bad, actually. It's when you've got apples and Tuesdays. Nowhere near the same. So it's important to get the physical, technical aspects right. You also need to know, you know, is it a big quantity? Is it a small quantity? You know, are we looking at the in-service costs, the operating costs, the support costs, or is it just the development or the manufacture or the construction? You need to be very clear. You also need to be clear and get the ground rules sorted out. What economic conditions are we talking about? Are we talking about today's economic conditions? Are we doing an estimate for 5 years' time? Are we doing an estimate including outturn costs? In other words, the year you spend the money, that will be their cost. So in other words, inflated. Are you talking about discounting? If you work for Treasury, you have to discount your costs. So there's many ways of presenting that, and I'll talk a little bit more about that later. What currency? Seems easy enough, doesn't it? Where in the UK we use pounds. What if all your money's estimates and quotes coming in dollars? Or euros? Well, not euros, keep away from them, but things like that. You need to be very clear on your ground rules, and you need to document those. So there's really a process you go through. At the start of any program, I always start off, it's an obvious statement, with a startup meeting. I like to get all the relevant stakeholders involved. I like to be briefed on what the project is and what data I'm likely to get. And what is the outcome? What do you actually want? Is it just a high-level rough order of magnitude estimate, or is it a very detailed estimate? Where are we in the program? I like the stakeholders to be there because I like to know what data there is available. And is it going to be available in the time frame? It might not be available today, but it'll be available in 3 weeks' time. And I've got 2 months to do this estimate. That's fine. I know it's coming, and I've got a go-to person to get that. Now, some organisations have a checklist for this, and that's very useful. You work out what you're getting, who's responsible for it. If it's not available, and estimators are data hungry. We want everything yesterday. We want the world. We're not going to get that. We always ask for it. We're always disappointed, but we have to work around that. But if we know what's available from the start, we can work around that. So we have a startup meeting. We understand all the technical aspects, what we're trying to do, of the candidate solutions. And normally there's more than one. There might not be one solution. So you need to know alternatives. We do the data collection. And that's the biggest task by far. Collecting all the relevant information, checking it. And that's your evidence to support your estimates in the future. It's important to do that. We document that. I always try to document the raw data I've received, and then what I've done to it to make it normalised to be able to be usable. Normalised, maybe bringing it into different economic conditions, getting more facts, bringing a number of different facts together. Sometimes I'm getting the same bit of information on the same project, but it's conflicting. So I need to understand, well, which bit of that's right. Then both might be right, but they may be based on different circumstances. I need to check all that and normalise it. Document it. Do my estimate. Doing the estimating is trivial. It's a lot of calculations often. It's making sure you've got the evidence to support what you're doing. And normally there's a lot of calculations. So you've got to make sure it's documented and clear. You validate the estimate. When I've had teams of, I used to have a team of about 40 estimators who work for me. So when I've had those, I've had somebody more senior or different group in the, maybe 2 or 3 are working on a project. I've had another estimator come and do a peer review. And that's the hardest review you ever do as an estimator. You think talking to your boss or your board of directors is hard. It's not. When you're working with a peer who's working the same team, you don't want to make yourself look an idiot. So that's a hard thing to do, to get one of your peers to check yourself. Because if you've made a mess up, if you've messed up somewhere, you're going to have to work with this guy in the future. And it's embarrassing. And we all do it. We all do it. However long we've been doing this, there's always something there's a chance there's something you've missed. So you have a peer review. But you also then have your estimate validated. And I'll come on to validation and verification a little bit later on. One of the things we find, there's a lot of uncertainty about your estimate. Again, it's something I want to talk about. And you often have concerns whether you're covering all the scope of what you're trying to do. So you run sensitivities. If you're manufacturing, for instance, you want to manufacture more items or less, you're not sure how many. You may test, well, if I make another 1,000 or another 200, what effect does that have on my costs, for instance, as an example. So you run sensitivities, and you see where that goes. It doesn't make a big difference. If it's not a cost driver, don't worry about it. But if it is, focus on that when you're doing your estimating, on those things which are the cost drivers. You also need to do risk analysis. It's not uncertainty analysis. Uncertainty is one thing, risk is another. There's 2 different things. You get uncertainty on risk, you get uncertainty on your baselines. There's 2 separate aspects. People use the words interchangeably, but they are different things. So you then need to look at what risk could happen. Again, something I'll talk about later. And you document it and present it. Now, it's not a black art estimating. Sometimes it feels like it, even when you're an estimator, you've been doing it a long while. But we don't just throw darts at the dartboard and pick the right answer. Not always, anyway. Sometimes we do. Okay. There's many different techniques, but what really we're doing is, as I said earlier, the estimating part of it is fairly trivial, in inverted commas. There's just a lot of it sometimes. We have to break it down into small chunks we can do simple calculations on. So typically we build a tool, and then we populate it with data and we create a model. But there are some bespoke models out there that can help you already. They're already developed for you, so there are commercial models. A lot of them are around what we call parametric modeling. I'll talk about that in a second. But there are other techniques, like analogy. It's a lot easier to estimate something if you know something else. If you know a person's size, and you're trying to estimate somebody else. It's easy. If you know a milk bottle, but you want to know what a carton looks like, you've got an idea. You've got something to benchmark against. So you use analogy. Scaling up from something, again, similar to analogy. Or you can do detailed estimating. This is where you go down with detail, and if you need 3 people, you work out the rate for 3 people for how long you need them. So you go into the detail of that. But there's usually, if you're trying to do an estimate of the whole life cycle, for instance, of a project, there's usually not one single model that will do the whole thing for you, unless it's a bespoke model that you've developed purposely for that task. Parametric model, I won't go through all of that, but really parametrics is all about, you've got data on past projects, you bring it together and you work out what we call cost estimating relationships. Something's driving that cost. For instance, if you're looking, and you can go on the website for this, if you're looking to build a new house or an extension, say a house, what you do, you give it things that might drive the cost. For instance, it's got 4 bedrooms, 3 reception rooms. You put that bit of information in, they may be the things that drive it. Ignore the fact that you've got to buy it in London, it costs a lot of money because it's land. Ignore those facts, actually build inside of it. 4 bedrooms, 3 reception rooms. That should give you an idea of the cost, 500,000 or whatever the figure is. That's a parametric model. You use 2 or 3 10 inputs and it gets, the calculations are already built up for you, it gives you an answer. There are secondary things. What if I want an ensuite bathroom, or 2 ensuite bathrooms? That's an extra cost. But you put that in as a secondary cost driver, and you come out with an answer. Now these tools are very powerful, they're very general, you have to tailor them to suit your own circumstances, but they are very powerful, and used often at the front end of projects, when you don't have anything else. They're good, and also good sanity check on a more detailed estimate. Analogy. The quote there says analogy is one of the most overused words in the English language. I think they're right. But analogy estimating is a technique I've just mentioned earlier, where you can understand what something looks like, weighs. For instance, if I'm trying to work out how much a felt tip pen would cost, if I've got a pen and I know there's twice as much ink in a felt tip, I just say it's analogous to that, but it's going to be twice as big, or twice as thick, or twice as long. You can do that by analogy estimating. It's subjective, it's not absolutely accurate, but when you're using this technique early on in the project, it's not bad. And you get quite good at doing those sort of things. And there are tools around that help you do that, using pairwise comparison and things like that. So, when do you use these different tools? Right at the front end, concept, typically use analogy and those sort of techniques. Going through the development stages, you can use analogy and parametrics. And these aren't mutually exclusive. You use a combination. Sometimes you can do a more detailed estimate for one thing, but you don't have anything to base it on for another. So you combine the different techniques together. When you're getting into production or construction, you can do a detailed estimate. And then you've got actuals. Now, what's that got to do with estimating, you're thinking? Well, actually, how do you think we do the analogy, and how do you think we do the parametric? We collect actual costs. We compare that to the estimate, we come out with an estimated ratio, and understand it. We improve our metrics we use to do that estimating by using actual costs. Taking into account the specific considerations, what's happened on that project. Because always things happen. You may have an extra risk, you may have had a gas explosion, you may have had some complication. You need to try to bring those things out. and try to normalize those actual costs as well. But we use actuals to help us do future estimating, helps us learn on mistakes, if you like, or inaccuracies on past estimates. Data collection. The quote, I stole that from an American presentation. I'll have to come over here to read it. I'll probably read it on here if I put my glasses on. This came from an American presentation, and it's about the UK and the revenue. I think it's great, though. It says the perception, or the problem with collecting data, the government are very keen on amassing statistics. They collect them, add them, raise them to the nth power, take the cube root and prepare wonderful diagrams. But you never forget that every one of these figures comes from the village watchman who puts down what he damn pleases. Well, that's okay. Silly quote. I think it's true. You collect data and you believe it. You have to check it. You have to correlate it with other data to prove it's accurate. Okay? But we rely on getting data. We need data for lots of reasons. So I'm going to talk about the data requirements. I'm going to talk about where you get that information from to support you, gathering that data, normalizing it, and recording it. So what do we need data for? We need historical data, actual data, as I just mentioned. That helps us work out, if you like, baselines, rates to use in future. You may have a rate for doing, I do some work for Network Rail, and one of the things they've got rates for how much it costs you to lay a track or take a track up or tamp the lines and things like that. How have they got that? They've collected lots of data in the past, and they've updated that data. And they use it for estimating the future. They've done it millions of times. So you'd imagine it's quite good. But there's complications as well. What if it's a different type of track? What if it's in a tunnel when it's confined spaces? You can't use the engineering trains. So there are different circumstances where you use different rates. But they've collected that and they're getting pretty good at it. But you can't always do that when it's a future technology you haven't done before. So if it's something you've done many times before, very useful. You can use it for parametrics, for analogies, for building bespoke models for yourselves, and calibration existing models or commercial available models. So it's very useful to get, we rely on getting good historical data. We also need data for the candidate solution you're trying to estimate. You know, be it one option or many. You need to describe what that is. You need to tell us physically what it looks like, technically what it looks like. Is there a drawing? Sometimes the early days are just a sketch or an idea in somebody's head you're trying to pull out of that person. We need to know the program you're trying to do. So we're collecting data about the future program. When do you want this delivered by? For instance, how many? And the economic things like, you know, do you want it in pounds, do you want it in constant costs or future costs? Those sort of things. I'd say there's often more than one option. If you're doing a good job, you shouldn't just do an estimate of one solution or one option. There could be different alternatives. So we need the cost, the effort, the actual cost and the effort involved, what type of effort, scale of effort, schedule, what phases, what the labour rates are used, any base rates. For instance, where you're doing taking the track up, that's a base rate. So much a metre. You just have to work out how many metres you've got to do your estimate against. And supporting technical information, a description. I've always said if you can describe a system to me, I can estimate it. I didn't say how accurately I can estimate it, but I can estimate it. We can all do an estimate, but obviously you need to have a qualified estimate. And how are you going to use it? If you're trying to do in-service costs, you've got a piece of equipment, you need to know what's its use, what's its reliability, what's the sparing like, what's the operations like. So you need to know all about that sort of information to be able to do it, if you like, a life cycle cost or an in-service cost. Sounds very good, but where am I going to get all this information? Remember, I ask for everything, and I'm usually disappointed, but I expect to be disappointed on the data I receive. But if I don't ask for it, I don't get it. The more data I get, the more I can correlate the data I have got, and the better estimate I can do, I believe. Whole range of data sources, from documentation, from previous projects. You can actually see the hardware, the software, whatever you see software. You can understand what the software does. How many lines of code. You can look at the hardware, you can look at construction, You can go to the sites, all sorts of things to collect that data. Don't forget the people who have worked on past projects of the same kind, or even the people who might be working on this project. If it's a bid, for instance, they'll have technical knowledge. There's a planner to work with. You know, how are you going to execute this? We just had a presentation on planning. You need to work very closely to get the work breakdown structure and the execution. Understand how it's going to be done. You need to work with the project engineers, the project managers, the sponsors. Everybody can provide good information to you. You don't always have time to talk to them as much as you can. And often they don't have the information. And often they'll give you misinformation, not on purpose. They just don't know the right information. I think they're being helpful, but you've got to sift through that. As I said earlier, we don't just collect all this information and use it, you know, whether it's good or bad. We have to make sure it's the right level of quality. So we have to normalise it, to bring it in. Typically you might get data, it's very good data, but it might be 3 years old. And you're trying to do an estimate now, you have to inflate it or do something to normalise it to today's economic conditions. Might be in dollars, might be in euros. So you have to use that. The technical information may not be in the right format. You need to bring it to, if you like, a common condition. You need to understand, was there an extra allowances put onto that if it's a cost? You know, what was included in that cost? Is it still relevant? At the end of the day, you're trying to build up a body of evidence to provide a support to your estimate, and this is important. The numbers are important, but this is one of the most important parts of it. Data needs to be checked. At the end of the day, you're providing evidence, and that's the evidence you go forward on and do your estimating. The important thing, though, once you have normalised that, you document it in what we call a cost data assumptions list, or many different words. But it's the known data you put in there. You put in the general assumptions, and then there might be specific option assumptions as well, and you document that. You also include the exclusions. Include the exclusions, I think is the right way of saying it. But you say what's not included, because if it's an interface with another project, who pays for the interface? You know, if there's some furnished equipment that somebody else provides to you, do you have to still pay for that, or is it free? You need to document those things to make sure it's absolutely clear, because it may be that you've forgotten it. Unless you write it down that it's an exclusion, have you forgotten? We don't know. If you're checking, one of my jobs is to do a lot of independent verification and validation of estimates. When I go in, I look at, it's just as important to me to see the things that aren't included as those that are included. Then I know the person's not forgotten it. So, we've got a cost estimate. What do we do with it? This is where we come into the cost engineering and further. So you have to do something, or you don't have to do something, but you produce an estimate and you need to be able to do something with it. There are many different ways of presenting your estimate. You can do it in detail, you can do it at a high level, but there's different ways of doing that. Outturn costs. Outturn costs, to me, it's not universally accepted, some of these terminologies. Outturn is the year you actually spend the money, it's in those years. So in other words, then year cost. It's inflated. So in other words, my estimate will include, say, spending 5 million in 3 years' time. That's the amount you'll be paying. Not this year's cost that I need to inflate by 5% a year to get to that figure. It's already inflated. So that's what you should be paying as part of your payment plan. So it's outturn. So it's a cash cost in that year. Constant costs means I've brought all the costs back to today or whatever, a set time. So all my costs are today's economic conditions, if you like. November 2011. I think then. A bit worrying. But it's today's economic conditions. So what you spend in 3 years' time won't be the figure I've said. If I put it on an annual basis, need to inflate it, potentially, or it'll be a higher cost. An alternative way of doing it, and if you ever present and have to do an investment appraisal for the Treasury, you have to discount to net present value. And I've got a slide talking about that because it's important. That allows you to compare options when you've got spends in different periods of time. There are other normalised outputs you can do. You can look at the equivalent annualised cost. Again, that's a way of comparing different projects. Again, it's used as discounted. And there's things like rate of return. How quickly can I get my money back effectively? What's my rate on my investment? Now, some of us might not be worried about that, but the people who are lending you money and backing the project will be interested in things like that. Or we can look at cost indices, looking at different aspects of inflation, exchange rates and things like that. Okay, so what do we do with these estimates? We've got estimates in different formats, suitable, and sometimes you have to present it all these different ways, but it's a matter of pressing the button often. You've got it all set up, you just press the button and it does it for you often in models. You might look at the cost-benefit analysis. You know, again, similar to rate of return, when am I going to start to get payback on this? You can look at cost effectiveness, look at how effective the alternative options are and what's the cost and which is the most cost-effective solution. You can give yourself a target cost or give the designers a target cost. In other words, they've got a design to a certain cost target. Instead of design to a performance or technical target, they have a cost target. You can look at different budgets. You can look at benchmarking and cost control. You know, what's the objectives? So you get a budget, you use the estimate to create a budget, but then you need to see how well you're doing against that budget. You may have to do a new estimate to complete partway through the project. You may have to look at the variances against plan. Previous presentation was all about planning. So you put you cost load your plan, and then you see how well you're doing, so you have a cost variance. And you can produce from that earned value, and so on. But without the estimate in the first place, you can't do a lot of these things. We're doing the time. Discounted. I thought I'd just pick that up because anybody who works with government and works with the Treasury will know you have to present by discounting. Discounting is a technique effectively that if you're trying to compare projects that spend at different periods of time, how do you compare them in an equivalent way? You have to discount future expenditure. In the UK we use 3.5% unless you've got a good reason not to. It's 3.5%, so you discount cumulatively 3.5% per year. That's to say, if I'm spending money in 5 years on one project, I'm spending the money now, you're bringing their spend to an equivalent condition. What we're really saying is money in the future is worth less than it is now. We all know that, don't we? Yeah. That's the basis of discounting. So what you do, you discount future expenditure down to a net present value by 3.5% cumulative per year. You bring it back effectively to today's situation, and then you can compare different options. It's a way of comparing options with different spend profiles. The money in the future is really saying we'd like to have that benefit of that money now. It gives you an equivalent annualized cost. It's a way, it's a way of bringing different options together and compare them on a like-for-like basis. What about accuracy? You know, this is your uncertainty. This is your variability in your estimate. A lot of things affect the accuracy. Your approach, your scope of what you're trying to do, the techniques you're using, the data, if you've got historical data, if you've got a good description of what you're trying to estimate, the type and size of the project. It's ever so easy to do a small, simple project. We haven't even had problems with them sometimes, but it's a lot easier. You start going to a massive project, there's a lot more uncertainty, and there's layers of uncertainty as well. Also depends on the team and the individual doing the estimating. How prepared are they to overcome the uncertainty, if you like. So we've got uncertainty in source data, in assumptions, in the modelling approach, and so on. Take an example of exchange rates. If we're trying to bring, people say, well, we've got estimates, we want to do estimates in different currencies and bring them together. Well, yes, you can present some of it in dollars and some of it in euros and some of it in pounds and some of it in won or whatever. But really you want one figure, don't you? Because at the end of the day your budget holder wants to put one number in. So you typically bring them down back to one currency. Be it UK pounds or whatever, you're bringing that one currency together in. What do you use? You use exchange rates. Now, which exchange rate do you use? Today's, last week's, next month? Next month would be good, but okay. What do you use? You have to set it a certain date in time. And you say, I'm going to use $1.60 to a pound, or whatever you agree. But what happens between the time you do that estimate and the time when it goes to a budget, and then you've got to use it? A lot of uncertainty about the exchange rate. We've seen that. I used to work for, do some work for an American company, and in the period I was with them, it went from $1.50 to $2.10, and back down to $1.50. So trying to work with them on that project, which was a bit of a nightmare. Changed, and that was in 2 years, 3 years maybe. But it's important, whatever exchange rate you use, you document and you agree, and you have some sort of mechanism to update that. Now what you might have is a float, or you may hedge your future spend on in dollars. You may hedge that. With a stock exchange, you may buy ahead, things like that. So there's ways of combating it, but that we're getting into risk management more than anything else. I'm trying to illustrate that there is uncertainty. Estimating is not an exact science. It's not science at all, really, in some cases. So there's uncertainty, which is one way. But there's risks that could happen, and they've got uncertainty as well. You're not sure exactly when the risk would happen, whether it happens, and so on. But there's several things that's definitely true. When you're estimating, you produce a single estimate, a point estimate, it won't be right. That's the only thing I can say. How wrong it will be, I don't know. But it won't be exactly right. There's uncertainty and there's risks to go on it. And there's several levels of risk. There's risks in the budget itself. You probably allow for a risk manager or a part-time risk manager. That's part of your budget. You're already allowing for risk management, if you like. Then there's the contingency reserve. That's the amount where you allow within your estimate an extra amount in case of risks. Whether you probably give it to the project manager and say, well, I'm going to give you another 5%, 10% here to cover all these risks we've identified in our risk register. Good stuff. Nothing wrong with that. And if you don't spend it, we'll get it back. Okay, I can talk about risk management as well, but I won't spend a lot of time talking about that. There's a third one, which is the management reserve. Effectively, you have a program of projects, typically, and the finance side of it, take a little bit on the top of each one, add a bit, 2% maybe, 5% on top of that, and bring it into a slush fund, a contingency fund. And you may have 20 projects in here, in this program, so you try to get that money. One of those projects may be so serious, or political will, or whatever the reason is, they may be able to get that extra piece of money. But effectively, there are 3 levels. As an individual project, you may not get that. But where does that come from? Well, the estimator helps to work out what those values are. There's many techniques for doing the quantification where the risks are, and the qualification of what the risks are in the first place, identifying those, and then quantifying them, the total effect of cost on that project. Now we can use statistical techniques, which is the main way of doing it, but there's many more. We used to use method of moments years ago because computing powers changed, but years ago it used to take overnight to run a simulation. And you come in the morning and say, oh, well, it didn't tell you where, so you have to do it again the next night. A lot of you think I'm joking. It used to be a nightmare running these things. Nowadays, you run it in a nanosecond. If it doesn't give you an answer, you think it's taking too long. So you typically use some sort of Monte Carlo simulation, Latin hypercube, or something like that. And you come out with a range of results, typically a PDF, probability density function, or a cumulative distribution function. From that, I've got an example here where if you like, the S curve is a CDF, and from that you can plot what the 50% point is. So you come over from the right-hand side, go across, then most likely the 50% point is 30 million in this case. Now, if you want to allow a little bit more for your risk contingency, the middle one of the 3 I've just mentioned, maybe you look at the 80% point and say 34 million. So that 4 million is your risk contingency, effectively. That's quite useful. But you could also, in some organisations, I know they go to the 90% point, and that's a bit between your risk contingency and the bit you give on your overall programme to allow. So another way, it's another way of identifying the extra risks on your program, not your project. Again, just a thought there. Different organisations do it in different ways. Just a couple of final things here. Independent verification and validation. It's always important to have that done on a project. When I say independent from the team doing the estimating. You've got to make sure that it's fit for purpose. So whatever tool or estimate you put together is fit for purpose. It's achieving what you set out to do, and it's validated. That means the data coming in is from a good evidence. You've got a good evidence of the source of that data. You've transposed it right. It's the right information to put in. You've transposed it right. And the calculations, if it's a spreadsheet model, which typically most estimates are based on, that the calculations have been done right. And that's not always the case. It seems very simple. When you're doing thousands of calculations, we all make mistakes. So you need to check it and get a peer review to check it and go through that. And there's tools to help you do all the calculation checking. But you have to, in my opinion, and most of the organisations I work for, have an independent B&B as well. You need to make sure the tool does all the things you want it to do, but it allows you to do sensitivity analysis, the uncertainty analysis, and risk analysis. Just leave you with these final words. I'll probably have to read these because I can't remember these off by heart, so excuse me a minute. So the 7 tests of whether you've got a good quality estimate. Objectivity. Is the estimate based on sound data, based on facts, and so on? So in other words, has it got a good foundation? Honesty. Has it built honestly on that above data? Have you used it properly? Is it relevant? Is the data relevant? You know, if I'm doing a construction project, I don't want to be using software or hardware off an aircraft program. Is it the right sort of data to use? And that's an obvious statement, but it's not always applied. Estimators are quite crafty sometimes, what they've used. Logic, does the estimate make sense? Accuracy, is it fit for purpose? You know, you're not going to get plus or minus 5% accuracy when you're doing it right at the front end of a project. Don't expect it, you won't get it. And if the estimator tells you it's inaccurate, he's kidding you, and himself, or herself. Holistic, is it complete? Does it cover all the things? And is it integrated? And finally, is it clear? Is it easy to communicate with the person you're doing the estimating for and further afield? My final thought, if you produce an estimate with the documentation, you should not have to be there to explain it. If you've got to be there to explain it, it's not documented right. So if you've got to ask the estimator questions that aren't clear in the documentation, in the estimate itself, he hasn't done or she hasn't done a very good job. That's my case. Questions? I've probably got a nanosecond. Any questions? Completely stunned, sorry.
On the subject of accuracy, are there rules of thumb, maybe like business sense, on the kind of realistic levels of accuracy you could achieve as you go through those different phases that you were talking about?
There are. And I'm sure if I spoke to 10 estimators, they'd have their own rules of thumb as well. But typically at the front end, people say plus or minus 40%. 40. Even when you're doing a detail estimate, plus or minus 5. Now I think that's wrong, because I don't think it's plus or minus 40%, because I think however hard we try, we tend to underestimate more than we overestimate. So I think it might be minus 20 plus 60. If you're going to apply the same scale, I think we underestimate a lot more than we overestimate. Now it's not always the estimator's, sorry, it's never the estimator's fault. Sorry, I got that wrong. What it is, things change. And as an estimator, you've got to work with what the knowledge you've been given, but other things change in the pipeline. You know, the design may change, the program may change, and if you're trying to do an estimate in a stovepipe and you're not working with your colleague, which unfortunately some of my peers work in isolation, I think if I keep it to myself and don't tell anybody I'm powerful, I think you should be an integrated part of the team. And if you are, you tend to keep abreast of the changes. But there's a danger we don't keep abreast of those things, and you work in isolation. So that's one of the reasons why the accuracy. But often the reason why it's inaccurate is because things have changed and nobody's told the estimator. So, and specs change, technology changes and so on. We've got time for one more quick question.
When it comes to a big project, there's always the figure, like if this project is 6 million, or 1 million. But it never comes like, you don't know, there's your Monte Carlo, whatever, probability, what has been happening, whatever. If it is a big value, a big figure, then it may not be running in real life. Yeah? So how does balance taking into account when it comes to the
what you need to do is you always try to do get the actual figures at the end of the project, so you do it out to an estimated ratio, but you don't just do it at the top level, you go down and get the actual information at the lower level, and you can compare. And we've done analysis of past projects where we've looked at what's changed, and you find the program split by 6 months. Well, that isn't free, because you still have to have the resources and people around, and the equipment often. Find the technology or technical requirements change. So there's a lot of things change in the project, so you can actually map where things did change. The cost estimating wasn't that bad. It's not good, it can be better, but actually a lot of other things change, because one of the things you should do, even once you've let a contract, is do an estimate complete. So you can actually understand and see what else has changed. So you're actually monitoring what's going on.
Normally people have a feeling like contract 10 million, that's what can happen. So I don't know, integration across 16 million,
integration costs are difficult. Integration costs, a lot of these things aren't easy, but you can do them. You can do them. And what you do, you learn from the past. You learn on other projects. Let's stop now, stop going on. Thank you. Thank you.